Welcome back to Learn as you explore, your go-to place for mBot2 tutorials. Welcome to today's lesson on Pick and Place Robot. This is part 1 of the series where we will dive deep into understanding the logic before we start programming. More of the programming will come in the next tutorial, but it is very important and crucial to understand the logic first before you start programming. So definitely watch this video until the end so you have a solid foundation before you start programming it. If you're excited to grab the mBot2 or any accessories, check out the links in the description. If you use the links, I may earn a commission at no extra cost to you. This project uses the Smart World add-on pack from makeblock. The Smart World add-on pack lets you build 3 different types of robots using your mBot2 as the base. You can build a robotic carrier, which has a carrier at the top of the robot. You can build a robotic arm that has a servo motor to hold objects. And you can also build a surveying robot where the quad RGB sensor is mounted vertically, so you can do color detection using the quad RGB sensor. For this project, we will use the robotic arm configuration. However, we will replace the ultrasonic sensor here with the smart camera that we've used in the previous projects. Please use the links in the description to purchase the Smart World add-on pack. It helps support the channel. I may earn a small commission at no extra charge to you if you use the link. To assemble the robotic arm, use the instructions that are provided by makeblock. The one change that you would need to make is that in step 17, instead of mounting the ultrasonic sensor, you would mount the smart camera. Please let me know in the comments if you'd like a step-by-step assembly video with the robotic arm. I'll be happy to make that if enough people request it. Next, let's talk about the servo motor. With the servo motor, we can command specific angles and the motor will hold that position. For example, in our robotic arm assembly, when we command a 90-degree angle to the gripper servo motor, it opens up. When we command a 140-degree angle to the servo, it closes. This is exciting, isn't it? We can open and close the gripper by simply commanding a position value to the gripper servo motor. Now, let's move on to talking about the target X and Y values that we will need to set for ball tracking. In our previous project, where we implemented all directions ball tracking, we programmed the robot to command its left and right wheel power in such a way that it keeps the ball in the center of the camera frame. We achieved this by setting the target X and Y values to the X and Y coordinate values corresponding to the center of the camera frame. As you can see here, the center of the camera frame is right here, and that is exactly where target X and target Y are set to. However, this is not going to work for our project today. This is because if the robot tracks the ball to the center of the camera frame, the ball will not be close enough to the gripper. And if the gripper closes, it would not be able to pick up the ball. So what can we do to make the robot command its wheels such that it tracks the ball closer to the robot instead of the center of the frame? Take a moment to pause and think about this. If you said that we can change the target Y value, you are absolutely correct. The next question is, do you increase or decrease the target Y value? Well, looking at this camera frame, and the X and Y axes, we know that as the ball moves to the bottom of the frame, it gets closer to the robot. So we want to move the target Y value closer to the bottom of the frame. As we go from top to bottom, the Y value increases. So we need to increase our target Y value. We know that the bottommost value in the frame is 207. However, that is too close to the edge of the frame, so I'm going to use a round target value of 200. This helps because it is slightly above the edge of the frame, but still very close to it. When using a target value of 200, we can see that the gripper is able to pick up the ball just like we want it to. Great! So now we know what changes we need to make to our ball tracking algorithm that we developed in the last project. With these changes, the robot will track the ball until it gets close enough for the gripper to pick it up, and then the robot will stop. What do we do next? Once the robot gets close enough, we need to stop tracking the ball and switch to a different mode. We want to pick up the ball, turn around, then drop the ball. This means that we need to switch from the ball tracking state to the pick and place state. We need a way to detect that we are close enough to the ball and then make this state transition. How can we detect that we are close enough to the ball? Pause the video and take some time to think about it. We know the target y-coordinate and the ball's current y-coordinate. We can use this information to detect whether the robot is close enough for the gripper to pick up the ball. We can check if the difference between the target y and ball y is less than 3. This means that we are allowing a 3-pixel tolerance. If the ball is between 197 and 200, we are saying that is good enough. However, there's no reason that we cannot give the tolerance on the other side of the target, meaning that even if the ball is between 200 and 203, the ball will still be close enough for the gripper to pick it up. So to add this symmetric tolerance, we'll change the condition to check if absolute of target y minus ball y is less than 3. This way, when the ball y is between 197 and 203, a 6-pixel range, we will call it close enough for the gripper to pick up the ball. When this condition is met, we will switch to the pick and place state. If this condition is not true, we will continue doing all directions ball tracking. Alright, I know that was quite a bit of logic to take in. So let's just lay it out all on one page so we have a defined algorithm. We'll let x remain at 158, which is the horizontal center of the frame, but we will change y to 200, which is the bottom of the frame closer to the robot's gripper. Next, we'll start our forever loop. We then have the condition to check if the ball is close enough to pick up. If the difference between target y and ball y is less than 3 pixels, we call it close enough. If it is close enough, we want to stop ball tracking and switch to pick and place mode. In the pick and place mode, we will first stop the wheel motors and close the gripper. Since the ball is close enough, closing the gripper will help us pick up the ball. Once we have the ball picked up and held with the gripper, let's turn around and play the audio tone. And finally, opening the gripper at this point will help release or drop the ball. Now, if the difference between target y and ball y is not less than 3, this means that we are far away from the ball and we need to continue doing all directions ball tracking. We will also keep the gripper open just so it's not closed while we're doing all directions ball tracking. This algorithm that we've laid out here is the core logic that you will need to know in order to move forward with the programming part of this project. So take some time to take it all in and understand why we're doing each step here. If you have any questions, feel free to leave them in the comments or join my Discord community where you can ask questions and get answers from me as well as other peers. We welcome teachers and students in the community. The link to join the Discord server is in the description. If you're a passionate teacher, check out the educator packs I've put together, linked in the description. You also have a free lesson pack to check out before you make a purchase. You've done great work today understanding the core logic that we will use while programming this project. Stay tuned for the next tutorial where we will modify our all directions ball tracking block program and implement the algorithm that we defined in this tutorial in mBlock. The next video is going to be super exciting. If you found value in this video, please like this video. It helps the YouTube algorithm. Share the video with more people like you. Subscribe to the channel if you already haven't done so, and share this video with a friend you think might find helpful. Here are some of my other videos that you may find helpful. Happy programming, and I'll see you in the next one.